So in the last video, we had an equation like this, y equals x squared plus 6x plus 9. And what we decided was, if I asked you to graph it, well, you would recognize that, oh, is this a perfect square trinomial? And it happens to be a perfect square trinomial. Take the square root of x, take the square root of 9, take the square root of x and the square root of 9 is x and 3 times 2 is 6x. It's a perfect square trinomial. And this is, of course, easy to draw. All you have to do is shift our regular parabola to the right by 3 units. Now, what if we didn't have a plus 9? What if we had y equals, let's give an example, x squared plus 6x plus 10. What do we do in this case? What can we do in this case? Well, I can't switch it. It is not a perfect square trinomial. So what do we do? And the answer is, remember how we used to decompose? Well, we're going to decompose one of our numbers for a different reason. If this was perfect square, we already know it's exactly the same as above. Almost, except that's a 10. We could rewrite this as y equals x squared plus 6x plus 9 plus 1. Now I have my perfect square trinomial. Let's rewrite that in factored form. Y equals x plus 3 squared. What happens to this plus 1? Well, you just add it right there. Now it's easy to graph. Whoops. Now it's easy to graph. Now I know that I can just draw it. It moves up 1 unit and to the right 3 units. This is my origin now. Okay, and then what do? We just draw our parabola. 1, 3, 5, 7, 1, 3, 5, 7. And that's it.